So we have another set of algebra tiles, and they form this pattern. So what I want to do is I want to see if I can write an equation that models this. Now what you'll notice right away is I've got this kind of rectangle section right here that I'm going to outline with red, and that's going to be growing each time, right? But there's something that's not growing, right? Those other two parts that are outside of it. So really, when I come up with my equation, I know that the number of tiles is going to be, well, it's going to be that red section plus this these two green ones, right? And those two green ones are going to be in every single one. So those two green tiles. So I know that before even getting going, this is just going to be whatever the red square is plus 2. And if you've seen in the previous video, sorry, I said square, but I meant rectangle. If you look at this this rectangle, I want to write this, the number of tiles in this piece, as base times height. And if I can figure out the base times height of that, add 2 to it, I'll have the overall number of tiles. So let's see if I can figure it out. Well, same thing. I want to nickname this my first expression, my second expression, and my third expression. And I'm going to start looking at my widths. Sorry, my base. Right? Well, this has a base of 1, this has a base of 2, this has a base of 3. Well, this is kind of an easy pattern. Whatever the x is, that's what my base is. If I look at my 73rd arrangement in this, if I just kept going, guess what? It'd have a base of 73. So I know that my base is going to be x. Now I need to figure out what my height is. If I take a look at my heights in this problem, this has a height of 2, a height of 3, and a height of 4. You can kind of notice a pattern between the arrangement number and the heights. Every single time it's just one more. In fact, in my 73rd one, I bet you I'd have a height of 74. So whatever our x is, all we had to do is add 1. So our height is just going to be x plus 1. Now, I'm going to want to do a little bit of, and I'm going to nickname the tiles. I'm just going to say that that's y, and x is going to be the arrangement number. So I want to see if I can simplify this equation. So I'm going to do my distribution, and I'll get y equals x squared plus x plus 2. You can see this is clearly quadratic, and we can double check to make sure it works. If I look at my third expression, there's 1, 2, 3, 4 by 3, so 12 in the red, and then 2 on the outside for a total of 14 squares. So in my third arrangement, there are 14 squares. So I can use that fact to double check to make sure my equation's good. If I plug that in, I'm just going to take it up here to plug it in. That would be y equals 3 squared plus 3 plus 2. That'll be 12 plus 2, and what do you know? It's 14. So we've checked, and it's got the correct number. It models the situation perfectly.